Hello and welcome to SudoKanard. Here is a equal sum Sudoku by Indian author Akash Doulani. So the special rule is that whenever you have such a cross between four cells, it means that the sum is the same on both diagonals. And you need to know that not all symbols have been marked, so there could very well be equal sums on those diagonals, but it's just not mentioned. So I put the link in the description to the blog entry where Akash issued this. I don't think I ever solved such a puzzle in the past, and I'm not sure where to look for a start, but this could be interesting. What happens here? Let's do some Sudoku to begin with. We see the 5s here, so there must be a 5 there. Can I know what comes here? Not sure, but I'm seeing that 4 and 9 are not in here. So 4 and 9 are in there. And something interesting there is that we know the sum of all of this, which is 45. And there's already 16 here. So the sum here should be 29. And here we have twice some things. So this should be an odd digit. It should be a 3 or a 7. So if 3 is here, then 26 is left, and both diagonals must have 13, which will be 4, 9, and 6, 7. That works. But if I put a 7 here, we're left with 22, and we should put 11 on each diagonal, and it's not possible because 9 would have to be with a 2, 4 would have to be with a 7. That doesn't work. So that's a 3, and we're left here with 4, 9, and 6, 7, and we must remember that 6 and 7 are on some diagonal. But 6 is not here, so 7 is not there. So we have 4 and 9 on some diagonals, 6 and 7 on the other one. And I don't think I can do anything better than that. Here the two 9s put a 9 here, and I can do the same. You see that 5 and 4 are somewhere in here. And 4 is not in here. So here we have 26, so the rest should sum to 19, and this should be an odd digits. Only 1 and 7 are possible. So I say 19. So if this is 7, then we're left with 12. 4, 2 on some diagonal, 5, 1 on the other diagonal. That works. If I put a 1 here, I need 18. 4, 9, and 2, 7. That works. Oh. So that's, don't know what else to do for this part. What about this? What about this? I'm seeing where should I look? Let's have a look at this. Here we have a 19. And we know from the 3s that there must be a 3 here. Oh, do I know anything about that? It can still be 1, 2, or 7. And this can still be 1, 2, no, not 2, 1, 5, or 7. And we know that those 4 digits have an even sum. Plus that's an odd sum, and the sum of all 9 digits is odd, so the remaining 2 digits should have an even sum, so this can't be a 2. So the sum of those 2 digits could be 6, 8, or 12. Is there anything more to say? I know that 2 and 8 are somewhere in here. And it's not the proper notation. So 2 and 8 are in here. And the remaining digit will be 1, 5, or 7. So what are the options? We could have 8 and 2 on some diagonal and 3 and 7 on the other one. That would work. So 1 here and 5 there is a valid option. If I try to put the 1 in here, that won't work. 1, 2, 3, and 8, you can't group them on the diagonals with equal sums. So that 1 has to be here or there. And with 5 that doesn't work either. With 5, I can't group 2, 3, 5, and 8 in such a way that the diagonals will have the same sum, so that's 7. And 7 will be grouped with 3, so it's on this side. And we know for a fact that this is a 1, this is a 5. Nice. And 5 is not in here. So 5 will be grouped with 1 or, was it 7? No, it was 5 and 4 and 2 and 7. Okay. Let's have a look at this. We only have 3 options, and they are 2, 5, and 7. Here we have, and actually 5 can only be here. That's interesting. That puts some pressure on what goes there. But first, here that's 1, 6, and 7, and that's not a 6. So let's have a look at this. We know that 8 is 3 more than 5, obviously. So this digit should be 3 more than this digit. So what are the options here? We have 1, 2, 4, 7, 9, but actually 7 and 9 are too big because this must be 3 more than that. 1 would put a 4, 2 would put a 5, but both of them are forbidden, so that's a 4 and that's a 7. Nice. And you can check that both diagonals have a sum of 12. So that's not a 7 anymore. And this here is a 1. So we know that the missing digit here is a 7. We have 4 and 5 on some diagonals, so the only way is to have 4 here and 5 there, and 2 and 7 on the other ones. Now let's have a look at this square. So what are the possible sums on this diagonal? 1 plus 2, but nothing will work with the 4. 1 plus 7, but 4 would need a 7 here. 4 would need a repeated 4 here, which doesn't work with this 4. So 1 is not an option here, that's a 6. 6 plus 2 would need 4 plus 4, so that doesn't work. So that has to be a 7, 13, so that's a 9, and that works. Well, it's important that not only we rule all the other options out, the remaining option must be valid. Here we still need 1, 7, and what? 1, 7, and 2. But 2 is not here. Here we have a triple, 1, 2, 7 triple, that's fine. And if I try to put a 1 here, that puts a 7 there, so that's 3 here, and this digit would have to be minus 4, which is not a valid option, obviously. And 2 plus 2 would work with 1 plus 3, right? 2 plus 7 would make this 1 plus 8. That would work as well. And there's nothing more to see there. This row needs 2, 3, and 9. So that's a 2. There's a 3 here and a 9 there. And we have a 3 here, so that's the 9, that's the 3. And knowing this plus that must be this plus that, so this must be 1 more than that. So it should be 2, 3, or 8, but 2 is not available, so that's not a 1. This 2, 7 pair makes this a 1, 7, 1. 2 plus 2, 1 plus 3, that works. And here, 4 plus 2, 3 plus 3, 4 plus 7, 8 plus 3, that works as well. This column still needs a 6 and a 7. But we know the parity of this by the same argument as before. Here we have an even total, and that's an even total, and the sum of the 9 digits is odd, so this must be odd. That's a 7. And it resolves this. We can remove 7 from here. So actually 7 is here. The sum on the diagonals is 10, so that's a 3. 2 is not here, so that's 8, that's 2. And that's some progress. Here I need 6 and 3, so that's the 6, that's the 3, and this 3 resolves all of that, so that's 8 and that's 7. That's 2, that's 3, and that's 6. So we're getting there. Here we need 1, 3, 6, and 8. So that will be 1 and 8 and 6 and 3 to have a sum of 9. But looking at the 3's in the grid, 3 can only be here with the 6. So 1 is here and 8 is there. Right, here we need 1 and 6. So that's 6 here and 1 there. Here 2, 5, and 8. And actually that's the 5. The counterpart of this is here, and it can't be an 8, so that's a 2. Here I need 5 and 8, so that's 5 here, 8 there. Here I need 4 and 9, and it will be resolved by all of this. This row needs a 4 and a 7, so that's the 4 here, the 7 there. 7 is not here, so it's here with the 6 for a sum of 13. This row still needs 1, 4, and 8, so that's the 4. And 8 is not here, so that's the 1, 8, 1, and a 2, and a 9, and that's it. So, very nice construction. A puzzle that's not too hard, I think. But you have to look at the right places. You see that the options were ruled out quite naturally, but it was not completely obvious. So that's the right amount of difficulty that I expect from, let's say, a regular puzzle, contest puzzles, things like that. Of course, contest puzzles can be more difficult. They have the right to be so. Thanks for watching this video. Thanks for Akash for all the great puzzles. And see you soon on SudoKanard.